So welcome once more, everyone. We will start the class officially now. So based on what we discussed yesterday, we ensured that we discussed about we made a revision on what ownership is. We also made revision on what borrowing, referencing, and then we move into functions. So who can give us a revision on all of these things I've made mention of? I mean, by now, there's nobody on the call that should say they do not understand ownership, borrowing, and all of that, if I'm correct. So who is willing to talk about it, basically? Yes, let's hear from Sylvanus, please.
Okay, so from my understanding, when you say ownership, the first value is the owner of the value. And if you try to copy from the first value, you have to use reference, which is used with an and sign to refer to the first owner of value of a value, which is to transfer from to a new value without changing the ownership. Is you'll be just referencing from the original owner. It's borrowing from the owner.
Excellent. Great. I like that answer. So yeah, that explains that we've got a very strong understanding on the ownership model, understanding what borrowing, moving of value is, and all of that. Thank you very much. Next, we went to talking about function. Can someone just give me the components of a function and what is a function at all? Then we can proceed from there. Let someone else talk, Sylvanus. Okay, Edwin. And others on this call that are always silent, I will mark your face. Mark Paul, I'm marking your face. I haven't heard your voice on this call. In fact, Edwin, please don't answer. Let's hear from Mark Paul. Mark Paul, can you tell us the component of a function?
Components of a function.
Yeah. Or what do we mean by function? Or what do we use functions for?
Well, we use functions to tell our program to perform a certain task. Meaning, sometimes you can give it an input, and that function is going to process it and give you a different output. And a function usually contains a keyword that indicates that lets your entire program know that this is a function. So you have usually a keyword. For this example, we have the fn, which should show that this is a function, and then we have an identifier, which is the name that lets us know that this is the name of the function, greet. Okay, and in some cases you have parameters, which the parameters are the things you pass into your function, like the inputs. You say, this is the input we're giving you. I want this specific output, in which our case, the output is say hello, and then the name that is the input.
Thank you so much. I mean, you've literally broken down what a function is, and that's exactly it. Thank you so much, Mark. I appreciate your answer, and I like the structure to which you gave your answer. So yeah, today we'll be talking about, we will proceed on functions, and we'll be talking about ownership when it comes to function. Now, when we were taking our class on ownership, we spoke about scope. And some of what I made mention about scope is that when a particular variable is inside a scope, the moment it goes out of the scope, that particular value is dropped. And at that particular point, you cannot reference a variable, that is a value, inside a particular scope from outside of the scope. But then, how exactly does this ownership model affect a function? How does ownership works when we are talking about a function? Here's how it works. Whenever you pass in an input to a function, that particular input, the function automatically becomes the owner of that particular value you passed into that function. So that means that if you create a string and then you pass it into a function, the function automatically takes hold of that string. And at that particular point, you can't use that value again. What do I mean by this? Let's go back to our code. Now, yesterday, we were able to create two functions, areas and perimeters, and all of this. Yeah, so let's comment that out. So today, we want to talk about ownership in functions, right? So we are going to start by creating a simple function, hello string. This function, hello string, is going to take in string. And it's not going to return anything. Instead, it's going to do a simple print. It's going to do a simple print hello. So it's going to print hello. And yeah. And inside of it, name. Yeah. So we have this function hello string. So this particular function hello string, what are we talking about when we are talking about a particular function that is taking up ownership? Now let's say we create a string name, and that particular name, we make it, I like my name, so I'll use my name. I'll use my name, Ayo. Who doesn't like his name? Come on. So I'll use my name, Ayo. And yeah, we have Ayo as a name. Now remember, we said functions are reusable. So in this particular case, we can call this function hello string more than one time. But then what happens when we pass in this name to function hello string? So let's say we say hello string, and then we pass in name. We don't have an error, right? And in fact, if we can go run this, what happens? Hello, Ayo. Everything works perfectly. There is no problem. But then what happens when we now, say hello string and we use name again? Notice what happens. We have a compiler error. We have a what? A compiler error. Why do we have this compiler error? That is due to the ownership model in Rust. So this particular value, IO, is a string, a dynamic data type. And so this dynamic data type, the moment it was passed into this particular function took hold of that particular value, IO. And what did it do to it? It literally became the owner of this value. So that means that if you come here, let's, for example, even if you are not calling hello string, if you come here and you just say print, and we say the name is, and we put Ayo, will it work? Name. We have, give me a second. Okay. So would it work? The answer is no. Why? This is because this name, Ayo, has been moved. And it has been moved inside this function, hello string. So this function hello string automatically becomes the owner of the variable of the value IO. So that means IO can no longer be used again because it now have a new owner, which is this function. Now, in some particular cases, we might begin to think about it that what then can we do in a situation whereby we do not want a function? Now, imagine we are trying to, imagine we are trying to create a function and we created the function, for example, it's this function hello string, and then we are now trying to, use the same value to call two functions. You get, for example, let's say we have another function that says, let's think of a very let's think of a very useful function. I don't want us to use a function that doesn't make sense. For example, this hello, what it just does is print. So I'm trying to think of a function that you can basically use just one value. You might probably want to use just one value for both of those functions. So let's think of it. Give me a second. Let me look at these ones we created before. And let me just do this, this, and then this. Okay, and then this. Now this. Now this is a static typed data type. Now in this particular case, notice that we are defining a particular value 10.0, which is a floating point. And now while defining this floating point, we are able to pass it into these functions. And it's basically able to work well because it's not a dynamic type. Can we see? Now imagine we are trying to do something else. Another dynamic type we have not spoken about, which I am keeping, is vec. Now, imagine we want to do something with the vec, which also looks like an array. We want to do something with it, and then we are passing in the same value just like this. It's a dynamic type. Automatically, the ownership would be claimed. So imagine this was a dynamic type this value. Immediately, this would throw us compiler error. But it's not throwing us compiler error. Why? Because it's not a dynamic typed variable. So that's the kind of example I was trying to bring up for something that basically reuse the same, the same value. So that's that on ownership. So moving on, we have return types, and return types is something I've spoken about very well, because from the function we created yesterday, this function area and function perimeter, we noticed that the return type they had was F32. Now in a situation whereby, let's say we keep this, let me create a function and then let's create a new function. Let me comment all of this. Let's not use all of this anymore. Let's create a new function. And yeah, so let's create a new function. Let's say function new func. And imagine this particular function takes in an I32 value, a I32, and then it returns a U32. Imagine what we want to just do in this function is to return the input. We are not doing anything again to it. Or let's just say the function, what it does is it multiplies by 2. So we say, we could as well do return a times 2, right? But we would have a problem. Why? This is because the return type is an unsigned integer. But what we are trying to do here is just integers. It's a signed integer. So for this, the return type you are creating for a particular function, what I'm trying to say is that it must be the exact data type. So that means you can create a function that has a return type string, and then what you are returning is something else. You are returning probably an unsigned integer, a float number, or you are returning even a Boolean. Imagine I put a Boolean here. What happens? We still have compiler error. That's because everything that you are trying to return must be the exact data type that you passed that you want to return. So that's that on return types. Another thing is multiple return types. Now, let's create a new function. The function I created, area and perimeter, we could create the function into, we could break it into just one. And we could say function calc area and perimeter. We could create a function like this. And what will the function do? It takes in the length, which, no, I don't want this to be capital, length, which would be an I32. Let's make it an I32. It takes in the breadth, which would also be an I32. And then what it returns is a tuple. It returns a tuple of I32 and I32. Now, this is the function. So now we could now start by saying area is equal to length times breadth, and then let's perimeter equals 2 times length plus breadth. And then at the end of the day, we return our tuple, which becomes area and perimeter. What have we done? We've created a function that basically returns a compound data type. Now, at the end of one of the classes, when we are talking about the compound data type, someone asked a question that in what situation might we want to use a compound data type? Now, this is an example of it. A situation whereby you might need to return a compound data type. You can think of another one. You can think of a function that calculates RGB. RGB, whereby the RG and B numbers are, they are increasing, decreasing, and it tells the particular color. It could be a function, and that function could just return a tuple of 3 elements. So you can just think of any situation as to your implementation, and you can create a function that basically does that. Now let's move on. But before we move on to results type, is there anyone at this point that has a question? Anyone? Divine, please, you can ask your question.
Okay, please, I didn't quite understand that ownership model, especially with the last examples you used for the functions.
Were you in yesterday's class?
No, not like ownership model, like the example you used for the function. There was something you said there. I don't know if you could just go through it again. I think I missed something.
Or you were in yesterday's class, so you understand what ownership is, right?
Yes, I do.
Okay, great. Okay, let's go back to that. Great question. So now, I was talking about this function. Now, while I was talking about this function, I mentioned that this particular function takes in a string. And now, the moment we pass in a variable to this particular function as an argument, this particular function automatically becomes the owner of that value. So that means that I created an example here where I created name, which has a value of ayo. It's a string, right? Now I created the function hello string, which I am calling here. I created the function here, right? Which I am calling here. And now while I'm calling it here, I passed in this name. Now this name could be anything. I noticed that, okay, I named the parameter here name, and I'm still trying to name the value name. So I just added underscore to differentiate it. So I named it name and I passed it in. What happens is that this particular function, hello string, automatically becomes the owner of this value, IO. So that means if I try to use IO again, I have an error. What is the error? Moved value. Oh, sorry. I didn't even, yeah. Moved value. Can you see? Borrow of moved value name. So I'm trying to call something that has been moved because this particular hello string has already taken the ownership of this value IO. And that's one important knowledge you have to have in Rust, that functions take up ownership. Now, one thing I was going to explain, which I really appreciate you, Divine, for bringing us back, is I was meant to mention what we are meant to do in a situation whereby we do not want just a function to take up the ownership. What then do? We make use of our reference. Can you see our reference here? So we make use of what? Our reference. And at this particular point, this string is not a reference. So that means that this particular value is not a reference. For us to have it work out well, we need to add reference at the front. So now, the moment we add reference here, automatically this one can then be called, and we would not have a compiler error. Why? This particular function, we have specified that the parameter that is coming into this function as an argument is now going to be borrowed. So it's going to be a reference of whatever value is coming into it. Are we getting that? So that means that if you are now trying to pass in that particular argument into the function, what happens is you need to specify that it is a what? It's a reference. So this particular string that we are passing in, which are this particular value IO, that we are passing in here, you have to add this reference sign in front of it to show that, yes, this reference, it's a reference because this particular function is taking in a reference. And at that point, the ownership of this variable, of this value, is remained. So name is still the owner of variable IO, or value IO, And so at that particular point, everybody can have access to it. So I can, at this point, call on hello string so many times. Sorry. Can you see? And there's no problem, no compiler error. This is because all of it is reference to this. No problem. A quick question. Can anyone tell me the difference between value and variable? Notice I've been saying value and I've been saying variable. Can someone tell me the difference between value and variable? Is my, okay, Adrian?
A variable is like a string. It can be a string. Okay, it's a string that stores something. Then a value is what is stored in a variable. Thank you.
Thank you. Thank you. But I don't like that. I really don't like how you put that variable. You can, okay, yeah, you are correct, Adrian, but I would have loved you to put it in a different way. But let's hear Victor, please.
Yeah. Good evening. So variable is what we use to store a value. It could be a string, an integer, any any data type, right? Then a value is what is being stored in that variable.
Thank you very much. Thank you so much, Edwin. Thank you, Victor. I'm happy that you guys got that. So is there any question on function ownership and referencing right now? I hope we got that clearly defined.
Yes. Thank you.
Okay, great. Okay, so where were we on our slide? Result type. Now, there are different situations whereby we are not sure of what would happen, in the sense that sometimes our code might return an error. I'll give an example. An example is, now I'm going to give two different examples, whereby these two different examples will just help you visualize a situation that is practical to you. First of all, the first example will be for those coming from probably the Web 2 background. Whenever you are consuming an API, there are probabilities that this API would return an error. How do you undo the error? Now, remember that when we were talking about functions, we specified that functions always have a specific data type. So what happens when we create a function that is consuming an API, and then this API returns an error? How do we undo this situation? How do we undo this error? That is where result type comes into play. So result type is what we use to undo the situation. Another scenario. Imagine you are writing a smart contract, and in this smart contract, the user has zero balance, and the user is trying to transfer 100 USDT or USDC from his smart contract, and the user's balance is zero. Remember, imagine you are trying to return the value that is being transferred. Now, this is just a situation, an hypothetical situation. Imagine you are trying to return the value that was transferred. What happens when you call that function? When you know that the balance is zero, because it's literally reading from storage. And then what is reading from storage is that it is zero. How do you handle this situation? You need to return an error. So how you return the error, we use what we call results. Now, result is not used to return only error. Now, results is an enum that is used to return a variant of an okay value and sometimes an error. Now, this error sometimes could come in form of custom errors. Now, these custom errors, it could also come in form of strings as an error. Now, the example we can see from this slide is a vivid example of that. So let's try to do it. Let's write out the code. Let's remove all of this. We really don't need this. We just comment this out, and then we create what we want to work with. So we said we want to create a function. What did we name this function? Divide. Okay. Divide. What the function does is it takes in an I32 and it takes in another I32. And at the end of the day, we want it to return something. We want it to divide A by B. But we are not sure if dividing A by B would be possible. Why? Because at the end of the day, we don't want a situation whereby B in this case would be probably a zero value, because we know when you say any number divided by zero is undefined. So we don't want a situation whereby B is zero. How do we handle this? We use this result. And then in the results, we have an I32, which we are trying to return, and a string. So this is what the result type looks like. So inside of it, we could create a condition statement whereby we say if A is equal to 0, then it should return an error. So it's going to return an error. And inside of the error, we would have a string. And what the string would say is cannot divide by 0. Now, we're going to check else. It should return an OK value, which says A divided by B. What is an OK value? An OK value is basically used to return, it's under the result enum, and it's used to return a value that is not an error. So when you use errors, the opposite of error is OK. So you have to wrap your result in an OK value. So that means, imagine we are creating this division and then we say A divided by B, and we did not wrap it in an OK value. That means we cannot what? We cannot compile it, because A divided by B in this case is returning a result. And so a result in this case has to be wrapped inside of an OK value. And this OK value we take A divided by B. So now let's try our code. Let's say what's our function divide? Let's say let's result equals 10 divided by 0. What happens? Let's print the result. In this case, we're going to print the result and let's go run it. Can you see? Attempted to divide by 0. Now, what happened in this case? This particular case, we notice that the error is not even coming from our code. The error is coming from where? From the compiler itself. So where did we make mistake while we were writing this code? Let's come back here. Notice what we did. We said the value of A should be 10, and then the value of B should be 0. So in our function, what were we testing for? We were testing for the value of what? For the value of A. So in this particular case, notice what happened. Our code literally ran into an error saying that attempted to divide by 0, notes with rust batteries. Now, this is a particular error coming from the compiler itself at runtime. So at this particular time, at runtime, it returned an exit. So it exited the thread. So that means that our code is not correct. So how should we have handled this error? We will come back to our code now. At this case, it's meant to be what? To be B. Because B is the one we were testing for 0 here. This is exact situation that happens whenever you divide or you do a computation that can't work, that is undefined. For example, on a computation that returns an error. You do something like that, and then suddenly you have what? You have the Rust compiler, panic. And we don't want something like that. That's in fact the reason why we are trying to do what? We are trying to work with results. So in this case, when I run this code again, what happens? Can you see? We now have a result. Let me drag this up so everyone can see the difference between what we did earlier. Notice that at this particular point, let me close this. There was a panic. Notice that this is red. That means the command ran out of execution. It did not execute. It exited the code. Can you see? At this particular point, it said the main thread panicked and then it exited the code. But then notice the other one. We actually had the code run. Why? This is because we actually handled the error properly. So that is a situation whereby you have errors and then you handle the error by using a result enum. So at this particular point, I want us to have a quick classwork at this particular point. But before we have that classwork, is there anyone that have any question based on what we've just spoken on result enums? Silvanus, please.
I didn't understand the last thing that you explained.
You did what?
I didn't understand that part of error.
Okay. Okay. So what I was saying is that now your computer, there are certain things that is kind of impossible. There are certain things that is going to cause trouble. Now, how do you handle this particular trouble? One of those trouble we experimented is 0. When you say 1 divided by 0, in mathematics, it is undefined, right? That's it in mathematics. Or when you say, in fact, any number divided by 0, it is undefined. How can you divide a number with nothing? It's undefined. That's it in mathematics, basically. Now, in that particular situation, how do you want your computer to compute that? And so we had a mistake, which was basically an opportunity for us to learn from. What was our mistake? Our mistake was that we were using A here. So we were saying that if A was equal to 0, it should return this particular error. But then inside of our function here, A was 10, which means this error would not be called. This line of code would not be called. Instead, it will automatically jump to the next line of code, which is line 173. Did you notice that? And now at line 173, where it jumped to that line of code, automatically the error is being sent. Now, how do we know that truthfully the error was sent at line 173? Let me clear this. Clear. So what I'm going to do now is I'm going to run cargo run. Can you see? Now, notice that the particular variable we are comparing is A. We are comparing A to 0. And in this case, where we are calling it, our A is 10. So this particular line of code passes. Then it comes on to the else part where we are checking it, A divided by B. In this case, A is 10, B is 0. So what happens? Cargo run. So when we run this, can you see? Now let's read what is coming out from the Rust compiler. It says, compiling Rust class version 0.1.0, which is the name of this, okay? Then it said, thread main panicked at what? At line 173. Can we see it? At line what? Line 173. Is this not line 173? And that's exactly what happened. So our code ran this function here, and so it came back to call the function which we declared here. Then it ran line 170. Line 170, if A is equal to 0, do this. Now, A is not equal to 0 based on what we put here, right? A is equal to 10. So it was like, okay, that passed. Then it moves on to line 172. Okay, it says, else, do this. And so it performed the action. And what was the action? The action was it to divide A by B, which it actually did, and then it panicked. And so it told us the panic error that it attempted to divide it by 0. So how could we have handled that error? What we should have done was we should have checked for B, because B is what we are trying to check. B is the denominator that we are trying to check against A. So it's the denominator that should not be 0. So if we said if B is equal to 0, which it shouldn't be, it should what? It should print cannot divide by 0. And so if we run our code now, notice that it actually ran successfully. That's why it is a blue tick. This is a red tick because it didn't run successfully. It panicked. At this point, it says the result is error cannot divide by 0. Can you see where we said the result is this, cannot divide by 0? Did you get that?
Yes, thank you.
Okay. So, everyone, let's quickly do a simple classwork. I want everyone. Okay. Arena. Is she still raising her hand?
Yes, please.
Okay, you can go ahead with your question.
I have another question.
Okay.
Okay, I was asking that, okay, like in some other programming languages like Python, you can handle more than one error at once. Like you have the if, then else if, then like everything. Yeah? So I was asking, can't you handle those both errors, like where you had like B is equal to 0, and this side you had A is the one that must fulfill that condition. So can't you handle both those errors at once?
Good. Now, your question is meant to be, is it possible to have different conditions? Now, I know I've not explained if-else statement because I just jumped into using if-else statement. And it's true I jumped using it because it was one like a situation I needed to do what? To basically use the result enum. Now, we were talking about the result enum. The result enum is completely different from an if-else statement. An if-else statement is used for conditions. You get? So if-else is used for if this condition is true, do this. Else, do this. Or if this condition is true, do this. Else if, do this. Else if, do this. Else, do this. Basically, that is basically what I was trying to, I've not explained that, but that's basically what a condition statement is used for, which I think I pointed it out once while I was talking about control flows in one of the classes, but I have not used it practically in the class, which I am doing now. But because what we are focusing on right now is the result enum. And this result enum is what is used to do what? To basically capture an error. So you undo an error properly by using the result enum. Do you get that? Now, let me share my screen again. Give me a second. Give me a second. Let me share my screen again. If I really want us to do this classwork, but I'll just quickly share my screen and show something just to answer Rennie's question. So now look at this example. This example we are using here, we could also add another condition to it. We could say else if A is equal to 0, and we could say Okay, 0. Why? Because any number divided by 0 is 0, right? Can you see? Now, our condition statement has elongated from if to else if to else. So in this particular case, imagine we were calling this. What is going to be the result? Now I'm curious. Now we have our value 0, 0. At this particular point, if we call this function, what are we going to see on the screen here? Can anyone tell me, if I can go run this, what are we going to see as the result? Can anyone tell me? I'm curious. Although just me doing this else if is just to clear what condition statements are for Irene, explaining that else if is not our focus, but our focus was the result enum. But now I'm back to another question. Look at this. At this particular line of code, we are passing in 0, 0 to divide. What will be our result? Anyone? Can everyone hear me? Yeah, Victor, please. You can unmute.
Yeah, that's okay. Please let me. You said, let me see. So I'm
What
passing
would-
0, 0.
Yes, yeah. Now look at this function. What would be our result?
Okay. Since A is 0, B is 0, so it's going to
Yes.
hit the first if statement here. So it will check, since B is equals to 0, to throw the error, cannot divide by 0.
Thank you very much. Thank you very much. Now, in a situation whereby we have this here, and then we have this here, what happens for 0, 0? Now, what happens in this case when we call this function? What happens? Now, remember that this function is now trying to divide 0 by 0. Will it say cannot divide by 0? Or what will it say? Anyone willing to try? Now, our time is fast spent. It doesn't mean we won't do our classwork. Divine, please.
It will return that okay 0.
Thank you very
That's
much. Thank you very much. Now, why am I asking this question? This goes on to speak about the fact that as a developer, what your code does depends on what you write. Now, as a developer, for example, remember that when I was writing this earlier, I made a mistake of writing this as if A is equal to 0. And then we had this panic. And then it gave me an opportunity to even explain what happens when B is not, is not accounted for, which is the denominator. And then we were able to now correct it back. Now, coming back to this, it is exactly what you write in your code that would be executed. So in this particular case, imagine you wrote your code like this. Immediately, you know that if that particular function is being called with 0, 0, it will first hit this first line of code and it's going to return 0. So imagine someone now asks you that, oh, I created the calculator, and the calculator, when I say 0 divided by 0, is it meant to give me undefined, or it is meant to give me 0? What's my answer supposed to be? Now, if you write a program like this, what your answer would give you would be based on what your program is. So that is why it's important that you are careful as to whatever you are writing. And this is where introduction of bugs happen. So you know that you want to first check if it is divisible by 0 before doing other checks to see if the initial one is 0. Now, this is we are talking about zeros because That is just what we are talking about right now. Now, it could be applied in other situations, other scenarios, whereby it is not zero we are talking about. So it's important that you always look at your code, and because your code would not lie, your code will do what you ask it to do. So that's basically it. I don't know if it's important for me right now to give the classwork because our time is fast spent. Do you guys think we should do the classwork or we should make the classwork? Oh, I think there's no need for us to do the classwork. Instead, we would use it as the assessment for this week. We use it as the assessment for this week. I'm happy this time what we are going to be doing is code. So I remember when I said the time for answering of, forms and optional question it would soon be over. I guess we are now in the time. So let's move further. Now, in this particular situation, whenever we return, let's go back. In this particular situation, whenever we return a particular result, how exactly do we handle this? Because notice that when I ran this cargo run, it told me that the result is okay, 0. Now, we do not want to see this okay. We are not interested in seeing this okay. And also, imagine, let's put this back in the original position. And yeah, so let's say we do this. We do not want to see the result is error into brackets, cannot divide by 0. No, we want to be able to undo this error. We want to see the original results by doing something. So what do we do in this case? We do what we call match. We use the match pattern to do one thing, to unwrap. So the match pattern can be used to do what? To unwrap. And then while unwrapping, you can basically match what is returned to something else, to another result, basically. But then in our case, what will happen if we try to unwrap this? What will happen is that, notice that this one is giving us this is giving us this. We would have to, remove this. So to do that, first of all, what we have here, we have to match it. So here is the syntax for it. The match keyword followed by what you are trying to match. And then you have an okay and an error. So if it is an okay, you can basically undo or do anything you want to do with the okay result. And if it is an error, you can basically do whatever you want to do with the error. Now, match is not just used for results enums. It is also used for different variants. Now, in a situation whereby you don't want to use an if-else condition, you can also use a match statement. A match statement is literally used to match different situations, that is, different conditions. Now, for example, while we were working here, we were matching B if B is equal to 0, that is, we were saying if B is equal to 0 condition, and then we are saying else do this. If it's this, do this, else if it's this, do this. For matching, we could also do the same thing, basically. So we could match our input, but then our input, we could match it to be equal to something and then compare it by the results. Now, the difference between matching and if-else basically is that for if-else, you can perform any condition. But for matching is basically you are matching just one value with different scenarios. You get it? So you can create a match statement that says match today. Now today, if today is is Monday, go to school. If Tuesday, go to church. If Wednesday, go to mosque. If Thursday, go to work. Now you can create a match statement like that. But now that match statement is matching Monday, Tuesday, Wednesday, Thursday to just one day. which is what? Today. But then for if else condition, you have to check if today is equal to Monday, then go to church. If today is equal to Wednesday, then go to continuously like that. But we are going to talk in an elaborate form when it comes to matching. So what I'm just going to do right now is I'm just going to re-implement this match divide, and then we are going to see the result and how it basically destructure the result of this okay value or this error, and how it's basically destructure it to give us a result. So we are going to do it, and we are going to do it here. So we are going to say match divide, divide, and then we're going to divide it and say the okay should give us an okay result and this. Now, let's say A is equal to 10. And let's say, oh, I didn't add A yet. A. And then let's say let B equals 20. So let's end this like this. Now, notice what we are doing here. This divide is basically still this, right? It's dividing it, and then also at the same time, it is checking it. If it is an okay value, it should return that the result is this. Now, if it is an error, it should return that the error is this. So it is comparing the two values here. So if it's an okay value, no matter what it is, it will destructure it. How is it destructuring it? It's destructuring it by creating an okay value here and passing in the value of the okay value that was returned here into these results. And then you can basically use it here. Now, this can go on to be even a bigger something, whereby this, oh, sorry, let me cut this out, Ctrl X, and paste it here. Whereby this particular result, you don't even want to print it. You want to now use the result for something else, like add results to 30. And then why do we have an error? That's because it expected what? An OK type, and it found an I32. Good. So let's return this first, and then we solve that. I will run. So in this case, our result is 0. It is completely different from what we had before, whereby our result was not structured. I think there's a problem here. Why is our result 0? 10 divided by 20 is what? That's 1/2. That's 0.5. Can someone tell us why our result is 0? Divine, please.
Because our return value is an integer, which is not a floating point. So it's going to take that as the result of 0.5.
Thank you very much. I think I gave you an expo when I said 10 divided by 20 is 0.5, right? I gave you an expo. But thank you very much. That's basically it. So that's basically it. So with that in mind, we can now create something beautiful. So now I was talking about destructuring this result and still using the result for something else. So just wait. Now let's try to make something bigger. And this time, let's just use something definite. So can you see? The result is 3. So it has matched it. It has matched it, and it checked if it is okay, it should print this. But if it is an error, it should basically undo that error well. So let's say B is 0 at this point, and we can go run it. What happens? Error. cannot divide by 0. Can you see it? Error. In fact, if we want to make it final, we can put this in front and say, and we run it, and then, can you see? Error cannot divide. Oh, this, I should put it in front here. Yeah. Can you see? Error cannot divide by 0. So this 0 is coming, cannot divide by 0, which is this, is coming from here. Can we see it? So basically, we've created a program that we are matching, and if, for example, this function divide could even be an external function. So what we are trying to do here is we are trying to handle a function that returns a result. And so you might not even be the one that will create the function that is returning the result, but you are using that particular function, and all you have to do when you want to handle that particular function is to do what? Is to match it, and then you destructure it and basically use it wherever you want to use it. So this is how we come to the end of our class for today. I'm going to send some questions which we are going to implement. First of all, some of the questions are very easy. They are very easy. The questions would be in coding, and the way I want you to do it is for you to submit your answers in a GitHub gist. In a GitHub gist. Now, I know I have not explained what GitHub and GitHub gist or what Git is. I know I have not explained that, but that is also part of the assignment for you to understand what GitHub gist is. You can go to YouTube, go anywhere. It's a personal research you can do by yourself. But notwithstanding, we are still going to come to that to explain what GitHub and GitHub is. But it's part of this assignment for you to submit in GitHub gist. I didn't say submit in GitHub also. Submit it in GitHub gist. And so your GitHub gist to be where you submit the link. So basically you submit the link, and then in our next class, if there's anybody that is willing to, explain what they have done, then we take that before we proceed to the next thing. So I'll stop recording. This is how our class comes to an end.